Okay, optional question, and just to kind of review some things with you. I know in Math 119 your teachers told you certain things about exponential and logarithmic functions. Let me just review those things that you were told. You were told for the exponential functions, f of x equals a to the x, that the a had to be greater than 0 and the a was not equal to 1. And this certainly led to logarithms with base a with the same conditions being met. All right? Now, again, that's not entirely true, but it's true if you're going to deal with real numbers. Right, so there's a series of events that happens in your life in mathematics where they don't tell you the full story. So, for example, going back to Math 100, you might have been told the square root of x squared was equal to x. And that's not true either, by the way. What is it really equal to? The square root of x squared you learned in Math 119 is actually the absolute value of x. Right, so there's a series of events that you told a bigger and bigger story over time, and then someone says, well, how big does the story get? It just never ends, right? But again, sometimes they tell you some things that aren't entirely true, right? So let's go through this over here, and I want to just review some things that they want to get, this answer over here, and that's got two problems now. It's got a negative base, which Math 101 teachers told you couldn't do, and it's got a negative argument, all right? So what I want to do is go back and just review a little bit with you about how we did logs of negative numbers with a positive base, by the way. So log base 2 of minus 8. And what we told you to do was, write in terms of natural logs. So we're going to use a base change formula. So a natural log of minus 8 over the natural log of 2. And then you were told to take, the rules of logs and write this down as a natural log of minus 1 plus the natural log of 8. The natural log of 8 doesn't bother me at all, nor does the natural log of 2. They're both pretty simple. It's a natural log of minus 1 that's troublesome, all right? So, initially we just simply wrote down it's pi I. And we derived that in a prior problem, by the way. And the natural log of 8 is, let's write that a little differently. Let's write that down. I'm going to erase that. I'm going to write that down as 3, whoops, sorry about that. 3 log 2. When I say log, I'm talking about natural log. Divide by natural log of 2. And so if you wrote this answer down, what would you get? Let's see, you get pi I over the natural log of 2. And then you'd get, natural log of 2 divided by the natural log of 2 is just 3. So if you're in the form that your teacher's math I told you, it would be 3 plus some multiple of I, and that's going to be pi over the natural log of 2 times I. And is that answer being listed? It is. It's right over here. Whoops. It's right there. All right? Not bad. There's a problem, though. And I want to tell you what the problem is. Let me start to erase things. And we'll review what you've were given in the very beginning of this section of the notes, by the way. And that is that the complex numbers, when graphed, there's angles and modulus and things like that. So arguments and a modulus. So let me go through that with you, and I'm going to talk about the complex plane with a real axis and an imaginary axis, and we're just going to talk about the number, a plus bi, and we're going to talk about minus 1 now. And where's that going to be? Right over here. That is, there's no multiple, it's 0i, so the a is just minus 1. So, the r is 1, and the argument is pi. But the problem is, this keeps going, and it hits itself periodically every 2 pi. So I'm going to say it's just not pi, it's pi plus 2 pi k. All right, so the truthful answer isn't just this single answer. The truthful answer is going to be equal to 3 plus pi plus 2 pi k over the natural log of 2 times I. And that's written for you right over here. Again, the understanding, and I could correct the notes, by the way, that k is an integer number. And I'll correct the notes, by the way. All right? So we've talked about that in the beginning. And what we're going to do now is we're going to try to see if we can do the next one. And initially, the next one's just using your head, right? So I want to do the negative base now. So log base minus 2 of the number minus 8. And I use my head like your teachers told you in 119. So this would be minus 8, and that would be minus 2, and that's the base, by the way. That needs to be put in parentheses, by the way. I can't say minus 2 to the power. It's actually the whole number, minus 2, raised to the power x. And I can say it looks pretty easy. And that's just x equals 3. That's pretty simple, by the way. And we used our head. We got it. Right? Unfortunately, we're missing some answers. So let's talk about it. And let's talk about going back to what we were doing. And the way we do that is we write down log base minus 2 of minus 8. I use my base change formula. Let's give it natural log of minus 8 over the natural log of minus 2. And I'm going to relate it back to what we did in the past. And I guess not a great memory, but we just did that, didn't we? So what are we going to get? We're going to get, let's be very careful over here. We're going to get pi plus 2 pi k. I got two problems, one on top, one on bottom. So k1i plus, by the way, that's the natural log of minus 1, plus the natural log of 8. And that does not bother me. What goes on bottom? Pi plus 2 pi. Now, it could be the same number. I'm just going to put down k2 because it could be a different number too. And that's I plus the natural log of 2. And I got to be honest with you, it doesn't look like this answer, does it? All right, so let's go through and see if we can get that. And we're going to do that, play around with it. And I'm going to take k1 to be 1. I'm going to take k2 to be 0. And what would you get in that case? Let's take a look at the top. You would get 3 pi, that's if k1 is 1, I, plus, well, the natural log of 8, we just did that before, it's 3 natural logs of 2. And at bottom, if I took k2 to be 0, I would just get pi I plus natural log of 2. I'm going to factor a 3 out from the top. And what do you get? You're going to get pi I plus the natural log of 2. And in bottom, I'm going to factor that. That's pi I plus the natural log of 2. And isn't that convenient? These cancel off, and we left off with 3, as we expected. But that's only one of the answers out of an infinity of the answers. Again, I want to remind you that the k's can be any integer. The ki can be any integer. Maybe I shouldn't use I, by the way. k1 can be any integer, and k2 can be any integers. Could they be the same integer? Of course they could. You could say 1, 1. You could say 2, 7. You could use your phone number, get an answer. All right? But again, we found 3. Thank you so much for paying attention.